Academy. Today we'll be looking at the topic probability. Probability is a little bit big topic. Probability and statistics, a little bit big topic. So we're going to take it maybe within a context of 3 or 4 classes in order to exhaust everything that we have to do. So without much ado, let's begin. Okay, first of all, probability is the study of chance. Probability is the study of a chance or the likelihood of an event happening. So the study of chance or the study of the likelihood of an event happening. So probability is something that you don't know how it's going to turn out. So that's why it's a chance. You don't know how it's going to turn out. The whole life is a chance, you know. So the whole life is a probability. Nobody knows the future. Nobody knows what is going to turn out. But we prepare for it, okay? We prepare for it. So the probability of success in life is how much effort we put in now, like by going to school, by doing your homework, by taking your studies serious. These are all probabilities. So we be probabilistic about the future. We are trying to work hard to get good grade, good results, good education, good practice, good experience, so we can feel it in a place, in the corporate environment, and get a good life, probably from all work from there. So it's a chance. But not everybody who put all this likelihood will eventually get a good life. And so it's a chance. So anything that you don't eventually know what the outcome is going to turn out is a probability, is a chance. So probability is the study of chance, the likelihood. But you should be hopeful, the likelihood of an event happening. So you're hoping you're going to have a good life. So that's why you're very serious. You take your study serious, you do your work, you progress from one grade to another grade. You finish primary, you finish secondary, you go to college or university, you get your bachelor degree, you do your master's, you want to get a corporate environment, get a good job and with good paying salary so you can have a good life onward. So although that's the projection, that is a probability. It's a probability. So probability is just taking chances as they come. Working hard, doing the things and taking the chance so that you eventually get what it is. Now, the formula for calculating probability or any probabilistic event is given as the number of favorable is equal to the number of favorable outcome, the outcome that you have, the favorable one, over the total number of equally likely outcomes. So the formula for calculating basic probability is to simply say that probability is the number of favorable outcome over the total number of equally likely outcome. So what this means is that, for example, if I tell you there are 20 students in a class, 8 do physics, 5 do chemistry, and 80 do mathematics. What's the probability of students who do mathematics? So probability of students who do mathematics, you take the favorable number for mathematics, the favorable outcome for mathematics. Let's say 50 do mathematics. So it's going to be probability of students who do mathematics will be 50, which is the favorable number for mathematics, 50, which is the favorable number for mathematics, over the total number of the equally likely outcome, which is the 20 students in the class, the whole number, the overall total. So this will be the probability will be 50 over 20. So if we simplify to the simplest term, this one 5 goes here, we get 3. We always put it the simplest term, and we put it decimal most likely, either in fraction or in decimal. 5 go here, we get 4. So it becomes 3 over 4. 3 over 4, I think it's 0.75 in decimal. So no probability answer is bigger than 1. Anytime you solve probability, the answer must not be bigger than 1. 0 point something. The answer has to be 0 point something. Okay, or fraction, a proper fraction. So probability answers the sum of all probability equal to 1. The sum of all probability is equal to 1. So what it means is that the P of A, if I say probability of an event happening, let's change the color. Probability of an event happening plus the probability that the event will not happen. Probability of an event happening. Now this is like the probability of an event happening plus the probability that the event will not happen. Probability that the event will not happen must sum up to be equal to 1. Must sum up to be equal to 1. So I put A prime here. If the probability of an event happening is A, the probability that the event will not happen will be A prime. For those who did their set, the complement of a set, you remember that. So the complement is what is What is the complement of the set is what is the universal set, but that is not in set A and set B, or it's not in set A as it were. Okay, so the sum of the probability must be equal to 1. Meaning all probability sum must be equal to 1. No probability answer should be greater than 1. When you say probability questions and you get answer greater than 1, then obviously you made a mistake. So you need to go back to your work and see what you've done wrong. So probability, let's say this is the probability of something occurring. This is something, probability of something occurring. Okay, this is the probability of something occurring. PA. PA is the probability of something occurring. The probability of something occurring. Then PA prime is the probability of the thing not occurring. So when you sum occurring plus not occurring, the sum must be equal to 1 only. Must be equal to 1. So probability of something occurring, this is probability of not occurring. For example, you say probability that it will rain today is 3/4. What's the probability that it will not rain today? So what's the probability that it will not? So when you see the word not, we're referring to this one, PA prime. Not occurring today or not raining today. Okay? Probability that it will rain today. Probability that it will rain today. Let's assume it's 3/4 or 0.75. What's the probability that it will not rain today? Because it's a probability. If I say it's going to rain today, it's a probability. It's a chance. There's a chance that it will rain today. Yeah, depending on where or which part of the world you are in right now, probability that it will rain today depends on so many other factors. The weather condition of the place, the rainfall rate of the place, the average sunshine of the place, the oceans and the seas, the availability of the place, whether the place has a forest or is a desert. So these are all factors that should be factored in. So if you're talking from the desert, you just say probability that it will rain today. It's not very likely that it's going to rain today if you're speaking from the desert. So I'm going to give you a probability spread spectrum. A probability spread spectrum that shows something that is not impossible, that is impossible, something that is unlikely, something that is an event that is equally likely, and then we have event that is likely, and then event that is certain that is going to happen. So we draw a diagram to show the spread spectrum of the probability. So probability that it will rain today plus probability that it will not rain today, all sum up to be equal to 1. So if I say the probability that it will rain today, which is probably assumed to be this P of A, is 0.75. Probability that it will rain today is 0.75. More often, we ask you what's the probability that it will not rain today. Okay, if they tell you the probability that it will rain today is 0.75, what is the likely chance or likelihood that it will not rain today? So it's simply using this formula. That's what it is. Because it's going to be 1 minus 0.75 to get the probability that it will not rain today. So which means this is 0.75 plus not raining today. I can call it X or whatever, anything that will make it faster for you, equal to 1. So to find the probability that it will not rain today, you simply say, you make it the subject. You say probability that it will not rain today, which is X or P of A. Let's use P of A. I don't. The board start lagging again. Okay. Probability that it will not rain today. So not rain. I put a prime on the A. Why I put a prime? Just to show that it's not happening. Okay. Probability that it will rain today is P of A. Not raining today will be P of A prime. P of A prime. So not raining today is P of A prime. You can use P of R, raining. Use R to represent raining. This will be 1. You bring this 0.75 to the right side, it becomes minus. 1 minus, this becomes 1 minus 0.75. Or 1 minus 3 over 4. So 1 minus 0.75 will give us 0.25, right? This will give us 0.25. So it will not rain today. Probability that it will not rain today will be 0.25. 0.25. Okay, so that's just that. Okay, I just want to bring to our notice probability sum. So probability that it will rain today plus probability it will not rain today equal to 1. Sum of probability must be equal to 1 in probability calculation. Now let's take a look at apart from giving the formula, we say probability is 0. When the probability of an event or likelihood is 0, then the event is impossible. It will never happen. It will never happen. If the probability of an event is 0, then the event is impossible. It's never going to happen. It's never going to happen. For example, probability that today might probably be the last day on Earth, the whole Earth to end, is 0. It's impossible. Today probably may not be the last day. It's impossible if you look at the factors. Or if you say probability that anything you can think of that you feel is impossible, it's never going to happen. Huh? Okay. Probably some people can. Right? Some people can hit the huge number of subscribers in 10 seconds, depending on how performing the YouTube page is doing. Okay, probably that you hit 1 million subscribers in 10 seconds. It's never going to happen, right? If you're a beginner, if you just start classes or start YouTube programs, right? That you're going to hit 10 million subscribers in 10 seconds or in 1 second. It's never going to happen for a beginner. Probably if you're a big YouTuber, maybe. Even it's not possible, even if you're a big YouTuber. 10 million subscribers in 1 second. It's never going to happen. So this is zero. This is zero. Okay? So this is zero. Then probability, when the probability is equal to 1, if the probability is 1, then the event is certain that is going to happen. The event is definitely going to happen. The event is definitely. So the spectrum of probability, we're going to spread it out. It ranges from 0 to 1. The spectrum of probability, the table or spectrum of probability, it ranges from 0 all the way to 1. So we can designate that, right? We can show that. It ranges from 0 all the way to 1. Let's assume this is the 0. This is the 0. This is the 0. And this is the 1. 0 means impossible. Remember we said that the spectrum of probability, when you have 0, it means the event is impossible. Something that is impossible, then we write 0 in probability. Anything that is impossible, anything that is impossible, or anything that is 0, we say is impossible, right? In probability. Anything that is 0, we say is impossible. Okay? Then anything that is 1, we say is certain. We've already defined these two concepts. Anything that is 1, we say is certain in probability. But in between 0 and 1, there are so many number of other possibilities. There are so many other possibilities between 0 and 1. Okay, between 0 and 1, there are so many other possibilities. So we have what we call maybe 0.25. 0 is 0, right? Then here we might have something like 25%, which is unlikely. We use the word unlikely. Okay, so I will use percentage, I will use decimal, I will use fraction. Because it depends on the text you're using. Some textbooks, they use percentage, some they use fraction, some they use decimal. So in this case, 25%, we say is unlikely. That event, if anything has 25% chance of occurring or of happening, that it do not have a very huge chance of likelihood. The chance of likelihood of occurrence is very unlikely. You are not saying unlikely does not mean it will not happen. You're only saying the chance is low. So you say it's unlikely. It's unlikely that it will happen, but there is a chance because this means one in fraction. It means 1 over 4. It means 1 over 4, which is 0.25 in decimal. In fraction is 1 over 4. Okay? So if out of 4 total chances, you only have 1, in exam they will say you fail. If you get 1 over 4, it's a failure. That's why we call it unlikely. The chance that it will happen is very very small. It's very, very small, right? The chance that it will happen is very small. The probability is very unlikely. It's not very high. If I say the probability that it will rain today is 1 over 4, what I mean is that even though there's a possibility that it might rain, but the opportunity or the chances of it rain falling today is very little. It's 1 out of 4 possibilities. 1 out of 4. So you can see it's not even equally likely. It's not even equally likely. It's very low. It's very low. So this is what we call the probability scale or spectrum. So I can call it probability scale. This table we are drawing, we can call it probability spectrum, if you like, or you call it probability scale. So probability, my marker start lagging. Okay, so bear with us. Probability scale. Or spectrum. Probability scale or spectrum. Spectrum. Okay, so that's that. Now we also have evil chance. There's what we call it evil chance somewhere around here. Evil chance. What do we mean by evil chance? That's like 50% evil chance, equally likely. Evil chance. Evil chance means 50-50, like what some people would say 50-50, or simply put 50%. So evil chance is 50%, which is 50%, 50%, 50%, which is infraction 1 all over 2. Infraction is simply 1 all over 2. And in decimal is 0.5. In decimal is 0.5. Okay? In decimal is 0.5. Then we have another one, which is likely. Okay, but if you go higher, they will give you more. They will give you more. They will say, after likely, there's what they call more likely. After unlikely, there's less unlikely. Here, you have less unlikely before unlikely, before more likely, and before more likely, before evil chance. You know, it's a lot, those when you go higher. But for this level, we can just simply keep it simple. We can simply keep it simple. So for likely, this is 75%. 75% chance that something will happen. If you say probability that today is 3 over 4, that's likely. That's a likely occurrence, a likely chance that it will rain today. So this one means in probability, in a fraction, this is 3 over 4. This is 3 over 4. And in decimal is 0.75. In decimal, this is 0.75. 0.75. Then we reach the certainty, the one where show 100% that it will happen. That one is 100%. 100%. Remember, 100% means 1. 100% means 100 over 100, which is 1. Okay? When we write 100%, it actually means 1, right? 100% means in fraction is 1. It's 100 divided by 100, which is 1. Okay? In decimal is also 1. It's 1. Okay, so that's that. This is 0 over 100. This one means 0%, which is 0 over 100, which is 0. Which is 0 over 100, which is 0. So it's 0 at the beginning. So these are the scale of a probability. Impossible event, like or likely event, which is 25%, which is 1 over 4 chance of something happening. We have evil chance, which is 50% opportunity of something happening, like 50-50. You say this thing, it may go this way, it may go this way. You have equal chances of either happening or not happening. That's 50%. Then we have likely, where you have more chances of that thing happening. And then we have certainty, where we are 100% sure that that thing is going to happen. So you can see probability spread from 0 to 1. Probability spectrum or probability scale spread from 0 to 1. Spread from 0 to 1. Right? So probability scale spread from 0 to 1. So now it's time for us to look at problems. To look at some problems and see how we progress or how we have progressed with the basic concept that we've explained. So the first problem is question number 1. Question number 1 that we're going to look at in probability is very interesting probability, so please pay attention. Probability class is very interesting. An ordinary dice, remember dice? An ordinary dice is rolled. You roll a die. So we may not be able to copy the question. Die, roll. So I just write dice, roll. Okay, dice rolled. An ordinary dice rolled because it's laggy, okay? Calculate the probability of getting a 6. Say we should get probability, calculate. Okay, let's write calculate. Sorry. Calculate the probability of getting a 6. So I just write a 6. Calculate the probability of getting a 6. You should calculate the probability of getting a 6. Okay? So, the first thing that should come to our mind is how many faces does a die has? It has 6 faces, right? So it has a number of favorable outcome is 1 because they say probability of getting a 6 because see we have 1, 2, 3, 3, 4, 4, 5, 6. Okay, these are the, if you take a dice, it has all these faces. It has the dice we use to play Ludo game, right? We use dice to play Ludo games, right? So it has 6 faces. Now they say a die is rolled, meaning you just rolled once. You took one die, you just roll it. So that one die has 6 faces. So when you roll it and you throw it to the table, it either comes up, the face that can come up could be 1, could be 2, could be 3, could be 4, could be 5, could be 6. Probability of getting 6 is that you have one chance. You have probability. Remember, is your probability is your number of favorable outcome over total and equally likely. So your favorable outcome is 1 because they say you should get a 6, right? Your favorable outcome is 1. Favorable outcome, so FO, I write FO. Favorable outcome over total. All the chances you have, they are 6. The Ludo has 6 faces. Since the Ludo has 6 faces, hence, you say 1 because a 6 is only 1. It's only one face. Getting a 6 is only one time. It will only appear once, which is this face. This face. Okay? So, which is 1. The favorable outcome is 1 because they ask you to get 6. 6 is only 1. Over how many chances? 1, 2, 3, 4, 5, 6. Altogether, there are 6 chances. So, we say 1 over 6. So, our answer for getting a 6 when a die is rolled is 1 all over 6. So, we're done with that. Right? So, probability of not getting a 6. What if the big part of this question is probability of not getting a 6? The probability of getting a 6 is 1 all over 6. Then the B part of the question, probability of not getting a 6. What's the probability of getting? You know when you get the probability of getting something, probability of not getting something is 1 minus probability of getting something. Remember that. Probability of not, if you get the probability of getting something, then the probability of not getting the same thing will be 1 minus probability of getting something. Is that okay? So which means not getting a 6 not a 6. So let's just summarize the language so that we don't. The board is laggy. Can't write a lot. Not a 6 will be 1 minus probability of getting a 6. 1 minus probability of getting a 6. Probability of getting a 6, remember we already got that to be 1 over 6. We already got that to be 1 over 6. So this will give us 5 over 6. If you do this subtraction, you get 1 minus 1 over 6, you get 5 over 6. Right? We get 5 over 6. So we get 5 over 6. Probability of not getting a 6 will be 1 minus probability of getting a 6, which gives us 5 over 6. Okay, so we're done with that. So let's go to question 2. Let's go to question 2, or probably a solved part of this question. Now, question number 2 is an ordinary fair die is rolled. Calculate probability of getting an even number. An ordinary fair die is rolled. A fair die, ordinary one, a fair die. Same question, right? Similar question. An ordinary fair die is rolled. Calculate the probability of getting even number. Now we can use this. What are the even numbers here? What are the even numbers here? We have 2, right? We have 2 even numbers. Odd numbers are 1, 3, 5, you know. Even numbers are 2, 4, and 6, right? So how many are they? 3. So we just say probability of very and even number. The probability of very even number. Probability of even number or of even number in the when the fair die is rolled. Probability of getting an even number when you roll a fair die will be what? Even number. Number we just write NO and put a small dash at the bottom. Probability of getting an even number is equal to how many possible favorable outcome for even number? There are 3. Favorable outcome for even number. 2, number 4, and number 6. So there are 3. So we write 3 over the total number of equally likely. All the numbers are 6. So we say 3 over 6. So 3 over 6 ends up to be 3 divided by 3, we get 1. 6 divided by 3, we get 2. It becomes 1 over 2. So if you want to put it decimal, you get 0.5. If you want to put it in decimal, you get 0.5. Okay, you get 0.5 in decimal. You get 0.5. Okay. Remember, like I said, you can either leave probability in the decimal or you leave them in the fraction. Okay, the third one. Now let's take a look at another question as fast as we can. The basic question. Okay. Let's take a look at some basic questions. We're going to look at also other questions as it were. Thirty students are asked to choose their favorite subjects out of maths, English, and art. Okay, this one we're going to make a table. Question number 3. We make a small table. I hope this lagginess will reduce so that we can be able to make this table. Otherwise, then to be difficult. Okay, so let's begin to draw. Okay, we have this. We have boys, we have girls. We have maths, the subject, English, and art. English, English. Then we have maths. We have maths. Then we have boys, girls, and then we have boys. We have girls. After the table, read out the question again. We have girls. We have boys. Okay? We have boys. Okay. Now let's say we have 7 here. Fill up the numbers. We have 7. We have 4. We have 5. Here we have 5 also. Here we have 3. We have 3. And then here we have 6. Okay, so this is what we have. You see, 30 students were asked. So total number of students were what? 30. So this is the total outcome. This is the total outcome. 30 students. 30 students. Okay, we already know that. So let's just keep that in mind. 30 students were asked to choose their favorable subjects or to choose their favorite subjects out of mathematics, English, and art. The results are shown in the table below. Now, here are the questions. Students chosen at random. A student is chosen at random. A student just chosen at random. Now, the first question is, what's probability that it is a girl, or he or she is a girl? What's probability that the student that is chosen at random is a girl? So that's the first question. So we already have a table. So probability where it becomes interesting, we have a table. We have math, we have English, we have art, we have girls, right? We have column for horizontal role for girls. Irrespective of the subject, the girls, they do. Several students, female students, do mathematics. 4 female students do English, and 5 female students do art. So we sum up the number of girls. So that's the first thing we have to do, right? We're going to sum up the number of girls. We're going to sum up the number of girls, right? Let's take a column that is conspicuous. We're going to sum up the girls. So if you add this, 7 plus 4 plus 5, 7 plus 4 will get 11, 11 plus 5 will get 16. So if we add this, girls will give us 16, right? Girls will give us 16. Girls equal to 16, right? We have 16. And the question is, what's the probability that a student that was chosen at random is girl? So, you know, probability, we say, probability is equal to the favorable outcome. What is favorable outcome? In this case, is the number of girls. Favorable outcome, which is the number of girls, over total equally likely, total outcome. Okay, total and equally likely outcomes. So this will be 16 over the total probability, total number of students in the class. The total number of students in the class is 30. So you say 60 over 30. So we can reduce this. Okay, we can find a common number that can go into 30 and 16. 4 cannot go into 30 without a remainder. 2 can, 2 go here 8, 2 go here 50. So we can stick to that. So if you reduce this, this will be 8. If you reduce this, this will be 15. So we get 8 over 15. 8 over 15. So that's the first part of the question, the A part of the question. Okay, we've done the A part of the question. The A part of the question. We've done that. Okay? You say, what if a student chosen at random, what's the probability that the student is a girl? So we calculate the number of girls over the total number of students in the class. That's the first one. The second part of the question says, what's the probability that it is a boy whose favorite subject is art? See, this one now has given another condition. What's the probability that it is a boy whose favorite subject is art? So we have to go to the boys and look for art subjects. So we have to go to boys and look for art subjects. So the B part of the question, we go to boy, the rule for boys, which is this one, and we look for art subject. Art is 6. So we can simply come and say, probability that is a boy whose favorite subject is art is 6 over 30. So the B, probability of boy and art, probability that the person is a boy and his favorite subject, the person is a boy and his favorite subject is art. See, I write B/A. His favorite subject is art Probability that the person is a boy and his favorite subject is art is how many students were taking art, boy students were taking art subject in the class is 6 students. So we say 6 over the total number of students in the class. 6 over the total number of students in the class. That's 6 over 30. 6 over 30. So this one, 6 can divide 6, we get 1. 6 going to 30, we get 5. So we can reduce this probability to 1 over 5. 1 over 5. Which probably maybe 0.2. You simplify to this one, maybe probably 0.2. Okay, that's that for that. Then let's go to the third one, the C part of the question. They're going to ask us. In the C part of the question, what's the probability of not choosing a girl whose favorite subject is English? Okay, here you have different way of doing this. What's the probability of choosing a girl? What's the probability of choosing a girl whose favorite subject is English? You can do the probability of a girl whose favorite subject is English, and then you say 1 minus the probability of a girl whose favorite subject is English. I think this is the easier way, but I will show you the other way. Let's do the easier way first. The C question says, what's the probability of choosing a girl? What's the probability of choosing a girl whose favorite? What's the probability of not choosing a girl? What's the probability of not choosing a girl whose favorite subject is English? Probability of not choosing a girl. So I go to the girl column. So why don't we calculate the probability of choosing a girl whose favorite subject is English first? Then we now find probability of not choosing a girl whose favorite subject is English. So anytime they say not doing something, you can easily calculate the probability of doing that thing first if the parameters are available. And then you now say 1 minus probability of doing that thing to get the probability of not doing that thing. Okay, so probability of choosing a girl whose favorite subject is English is 4 over 30. Probability of choosing a girl, we go to the girl role for girl. Probability of choosing a girl whose favorite subject is English is 4 over 30. But the question is not asking for the probability of choosing a girl whose favorite subject is English. The question is ultimately asking for the probability of not choosing a girl whose favorite subject is English. But like I said, to do this question easily, you forget about the not first, do the probability of choosing a girl whose favorite subject is English. So we take the probability of choosing a girl whose favorite subject is English. So we say, before we do the probability of not. So I will say probability of a girl. I'm looking for the probability of choosing a girl whose favorite subject is English. Girl English first. Let's calculate the probability of girl English, of choosing a girl whose favorite subject is English. When we do that, after doing the probability of choosing a girl whose favorite subject is English, we can now find the probability of not choosing a girl whose favorite subject is English. So the probability of choosing a girl whose favorite subject is English is, you come to the row for girls and look for the English column. So you see, it's 4 over 30. So probability of choosing a girl whose favorite subject is English is 4 over 30. 4 over 30. Mind you, this is not what the answer wants from you. The answer is asking the probability of not choosing a girl. So now let's calculate not choosing a girl whose favorite subject is English. So we say P. Remember you can say P girl English. P girl English. P probability of choosing a girl whose favorite subject is English. P girl English plus probability of P not girl English plus probability of not girl English. You can use N for not, but I use prime. We normally use prime. Girl, not girl English. I can write it like this in probability connotation. I can write it like this. Probability of not girl English. So I put prime here. See, prime. Probability of, or we put the prime outside the bracket. Equal to 1. So this is what they ask us to do, and this is what we did just now. We got 4 over 30. So we just substitute. P not P. Probability of not choosing a girl. Probability of not choosing a girl. Probability of not choosing a girl whose favorite subject is English. The not is the prime. You see this prime I put? When I put prime, I said you can put the prime outside if you so wish. Probability of not choosing a girl whose favorite subject is English is equal to 1 minus probability of choosing a girl whose favorite subject is English. 1 minus the probability of choosing a girl. 1 minus The probability of choosing a girl whose favorite subject is English. Of choosing a girl whose favorite subject is English. So 1 minus this one. So which means ultimately it's just 1 minus 4 over 30 that we calculated before. 1 minus 4 over 30. Remember, anytime you have 1 minus anything, 1 minus another fraction in another side, okay, anytime you have this one means 30 over 30. Remember that. If here is 1 over 2, this one will be 2 over 2. Always remember that. Okay? So this 1 over means 30 over 30. So it's like you say 30 minus 20. It's like writing like this. It's like writing like this. 30. Instead of writing 1, you can say 30 over 30. You can say 30 over 30 minus 4 over 30. So 30 over 30 minus 4 over 30. 4 over 30. Minus 4 over 30. Okay, so 30 minus 4, you get 26. You get 26. You get 26 over 30. You get 26 over 30. Okay, so that's the answer to this probability. Probability of not choosing a girl's favorite subject is English. Is that okay? So that's that for this question. That's that for this first part. Now let's take a question before we elucidate all that, before we go to Venn diagram. In our next class, our next probability question, we're going to use Venn diagram to solve problems in probability. We're going to use Venn diagram. We're going to combine the Venn diagram and probability together. But before we go there, let's take another question. I think one last question or thereabout. Yeah, one last question. We're going to do one last question, and then we will end today's class. And then we will go to relative probability and others in our next class. Okay, so one last question. Question number, this was number 3, right? Number 4. Now we're going to question number, okay, this was number 3. Now we're going to question number 4. Question number 4. Question number 4. Now, we say a coin, you know the coin, like the coin, the money coin, is toast. A coin is toast and an ordinary 6-sided die is rolled. A coin is toast and an ordinary 6-sided die is rolled. So we have a coin, we have a dice. You know, remember a dice has six. A dice has 6 sides. Coin, we have a coin. We have a coin. We have a dice. We have a coin, we have a dice. We roll a dice. You roll a dice. You toss a coin. You toss a coin, right? Toss a coin and you roll a dice. So these two, we want to make a table for both of them. Okay, we say a coin is tossed, the past tense, and an ordinary die, 6-sided dice is rolled. The coin has a head on one side and a tail on the other side. Obviously, coin only have head and tail. And the faces of the dice are number 1 to 6, obviously. Show all the possible outcome. The first part of the question is for us, the A part of the question is for us to show all the possible outcome. The first one says we should show all the possible outcomes. all the possible outcomes. Okay? The first one is between a dice and a coin, when you roll them and you toss them, they say we should show all the possibility or all the possible outcomes. Okay? That's the A part of the question, all the possible outcomes. So I think we'll be solving it one by one. Based on the one they ask, we solve it. So it says show all the possible outcomes. Show all the possible outcomes. Okay, so that's the first question. They say we should show all the possible outcomes. This is all the possible outcomes in a sample space diagram. So they want us to show it in a sample space diagram. So here we're going to draw diagram again. We're going to draw a table. Okay, so they want us to show all the possible outcome in a sample space diagram. So this is how you answer this type of questions in the exam. So we're going to show how to draw this, because this is very likely exam question. Okay? In a sample space diagram. In a sample space diagram. Okay? We're going to make a table. And we're going to see how this will play out. A die and a coin, put them together in a table. Okay? So for the coin, here we have coin. Coin is just head and tail, right? So here we have the coin. And then we have okay. This is the head of the coin. We make this one the head, and we make this one the tail for the coin. So we settle the coin side. We settle the coin side. Head, tail, head, tail, head, tail, to cover the 1, 2, 3 to 6 for dice. Here we have the dice. For dice, let's change. We have the dice here. Remember, dice is 1 to 6. So we want to make the dice on this side 1 to 6. Okay? And then we will label 1 to 6 here. So here's 1. Here's 2. Here's 3. Here's 4. A die has 6 faces. Here's 5. And here's 6. Here's 6. So we have 1, 2, 3, 4, 5, 6 for dice on this side. We have head and tail on the vertical side for coin. Is that okay? So if we fill up this one, we can now have, we can rule every part of this down. We can rule every part here down. This is what they want us to show, all the possibilities. Here you get a lot of marks for being able to do this. It's easy. Dice on the horizontal side and coins you put them on. Dice on the head part and the coin on the other side. Now what we have here will be head 1. We now fill both. See here, what is here and what is here you put here. What is here and what is here you put. So what? Here will be H1. We can change the color. Which color? This is blue. We can call this one H. This H and this one. We put the H1 here. For this space, it will be this H, head, and 2. So we put head and 2 here. H2. Put H2 here. For this space, is this head and 3. So you put H3 here. H3. For this space, you put this head horizontal and vertical. It's like coordinate. It's like coordinate. You trace this value and this value. So it's H4. Here you put H4. H4. Here you have H5. Put H5. Head and 5. H5. Here you put H6. Head and 6. Head and 6. So that's for the head column. Now the tail side, same thing, T1, T2, T3, T4, T5, T6. So you do the same here, T1, because you're not doing the tail column. T2, T2, yes, T3, yes, T4, yes, T5, and yes, T6. Yes, T6. Okay, so that's all the possibility they want us to show in the first part of the question. The A question show all the possible outcome in a sample space diagram. So this is what we have done. If this is 5 marks, you get your 5 marks. If this is 5 marks or 4 marks, you get your 4 marks. So showing this dice and coin together in the table. Is that okay? So this is one way of doing it. Now let's look at the B question. What the B question is going to ask from us. Probably you'll be needing this table to answer all the other questions. From the sample space diagram, it can be seen that there are 12 possible outcomes. Right? If you count all possible outcomes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possible outcomes. Let's see the question first. How many possible outcomes are there? That's the question. See, the B is asking you, how many possible outcomes are there? You say there are 12. Right? How many possible outcomes are there? How many possible outcomes? How many? How many possible outcomes are there? The board is lagging. That's why I'm not writing all the questions. How many possible? I just need you to understand what the question is. How many possible outcomes are there? So there are 12, right? So the answer is 12. The answer is 12. There are 12 possible outcomes. So we move away quickly. We've answered this one. The C part of the question says, what's the probability of getting a head on the coin and a 3 on the dice? A head on the coin and a 3 on the dice. A head on the coin and a 3, that would be 1 over 12, right? The probability of getting a head on the coin and a 3 on the dice. Come to the table. Probability of getting a head on the coin is this one. And the probability of getting a 3 on the dice, this is the 3 for dice, and this is the head for the coin. So we're referring to this place. They're referring us to this place. So they ask you what's the probability of getting a head on the coin and a 3 on the dice. So this is exactly what they are asking for. It's only one outcome, one favorable outcome, H3, over how many of total outcomes, which is 12. So probability of getting a head. So probability of getting a head on the coin and head on the coin and 3 of dice and 3 on the dice That's H3 is equal to 1 over 12. Is equal to 1 over. Why? Because there's only one H3 in the entire table, the entire possibility. 1 over, how many possibility? 12. So we say 1 over 12. So we say 1 over 12. Okay? So that's how we've answered that question. Now we go to the D part of the question. The D part of the question, let's see what they're going to have for us for the D part of the question. The D part of the question says, what's the probability of not getting a head on the coin and not getting a 3 on the dice? The probability of not getting a head on the coin and not getting a 3 on the dice. Right? Probability of not getting a head on the coin. So this one will simply be, we say P H3 plus P not H3. P H3, remember this, plus P not H3. P H3, this is the probability of getting a head on the coin and 3 on the dice, plus the probability of not getting head on the coin and not getting 3 on the die, which is P not H3, P not H3. I put prime, when I say not H3, we always put prime. Not H3, we put prime here. Okay? Equal to 1. Equal to 1. Probability of PH3 is what? We just calculated 1 over 12. Probability of PH3 is 1 over 12. 1 over 12 plus what we are looking for now. P not H3. P not H3. P not H3 equal to 1. Equal to 1. Equal to 1. So we just subtract. This will be equal to 1 minus 1 all over 12. 1 minus 1 all over 12. Remember I said 1 minus 1 over 12. The one whole number will be 12 over 12. The one whole number will be whatever this denominator is. Will be whatever this denominator is. If this denominator is 30, we will say here is 30 over 30. If it's 12, we'll say 12 over 12. Remember that. I've explained that in the previous example. So this one is like saying 12 over 12. So that you avoid using calculator, that's why I'm just telling you the quick way. This one is 12 over 12. 12 over 12 minus 1 all over 12. Minus 1 all over 12. Minus 1 over 12. This will give us 11 over 12 as our final answer. This will give us 11 over 12. Okay, so this will give us 11 over 12 as our final answer. This will give us 11 over 12. So this 11 over 12 is the probability of not getting a head and not getting a tail and not getting a dice. Okay, not a head and not a 3 on the dice. So this one gives us 11 over 12. Then the last question for this question is, what's the probability of getting a tail on the coin and an even number on the dice? Okay, we have to go to the table. The E part of the question, what's the probability of getting a tail on the coin? You get a tail on the coin and even number on the dice. Getting a tail, so this one, we have to go to the table. What's the probability of getting a tail on the coin? What's the probability of getting a tail on the coin? So there are 3 chances of getting a tail, right? And a tail and an even number, not just a tail on the coin and an even number on the dice. So it must be tail with even numbers. So we can see this will be tail and even number. So I can select this tail and even number. This one you cannot select this. This tail are odd number. You cannot select this as well. Tail and even number. Tail and even number. And also this one, tail and even number. Each one is 1 over 12, 1 over 12, 1 over 12. Each one is 1 over 12, 1 over 12. So probability of getting Probability of getting a tail on the coin, and you see there's and probability and means multiplication. Probability of getting a tail on the coin and an even number of the dice is the possibility we have circled. Tail on the coin and even number of the dice. This is even number of the dice, even number of the dice, even number of the dice. But you only consider for tail. You cannot do for head. So this will become, this one will be P of T2, P probability of T2 plus, this will be probability of T2 plus probability plus probability of T4, that's the tail and the even number. Probability of T4 plus the probability of T4 plus the probability of T6 plus the probability of T6. Probability of T6 plus the probability of T6 plus the probability of T6. Okay, so this one means 1 over 12, simply means 1 over 12 plus 1 over 12 plus 1 over 12. This one simply means 1 over 12 plus 1 over 12 plus another 1 over 12. Okay, so we add 1 over 12 plus 1 over 12 plus 1, you get 3 over 12. You know, right? If you add them together, not 3 over 36, you know, right? You're going to get 3 over 12. Because the denominator is same. Once the denominator is same, you just add the numerator. So you get 3 over 12. And you simplify. 3 divided by 3, you get 1. You always put fraction in the simplest form, or ratio in the simplest form. 12 divided by 3, you get 4. So our final answer is 1 over 4 for this case. Okay? So our final answer is 1 over 4. So that's all we have for our today's class. Thank you for joining us.